All right, so this is the assignment called Common Structures, Common Ancestor, and it's actually a coloring assignment. The coloring utensils should be by the door in that cabinet labeled number 22 if they're not already out for you. So normally I would be in class and I would be able to walk you through this, but since I'm not feeling so great, I'm going to do a video that kind of explains everything from home. This can help you finish this assignment, but it could also help you prepare for our upcoming test, which is still planned for Thursday. So let's rewind time a little bit. The very first vehicle, motorized vehicle ever created, it's the Mercedes-Benz motor wagon, produced in 1886, and this is pretty sweet, honestly. Excuse me. That's why I'm not in class today, actually. So this is the first vehicle ever created, and obviously there's a lot of differences between this motorized vehicle and the cars and trucks and whatever we drive today. But there still are some similarities. In fact, there's many similarities. And it was based on this model that we have all of the motorized vehicles that we enjoy today. So, looking at this, take a second, maybe even pause the video if you want, and see how many features that you can point out that exist as part of this first vehicle that we still see today in some form or another. I notice one, there's a way of steering it. This weird contraption, it kind of goes up into a handlebar type thing, and it's the way that you steer the vehicle. So, I mean, do we still have a way to steer cars and trucks and vans today? Yeah, absolutely. So that's still something they all have in common. I noticed. Oops, went too far. There's a seat, of course, and even right here, this lever. I didn't point this out earlier, but this is actually the braking system. You pull on that, and it's like the emergency brake. But yeah, here's where you would sit to drive the thing. Do we have seats in today's vehicles? Yeah, of course. There's an axle. There's something for the wheels to turn around, both on the front and on the back. Our vehicles have that today still as well. And there's wheels. Now, this one has two in the back and one smaller one in the front, so that's different than most of the things we drive today. But the fact that there's wheels is still common in all of our motorized vehicles, at least until we get hover cars, right? So, looking at the motorized vehicles that have come from that first vehicle, you've got like trucks, you've got motorcycles, you've got like the Ferrari, the Jeep, the tractor, even these side by sides, and they all have different purposes, completely different purposes. But if you look at the fundamentals of them, the basic elements, they all still have in common many of those same things. Is there going to be an axle for these two front wheels and these two rear wheels to spin around? Yeah. Is there something to sit on and steer with in this tractor? Yeah. Are there tires and wheels in this side by side? Yeah, absolutely. Is there a braking system in the Ferrari? Of course. So we still have these fundamental elements that can trace their lineage back through the years to 1886 when the first vehicle was created. And that's kind of our main idea of the day. So let's rewind time a little farther, 367 million years ago to be exact. There's this animal that is new on the scene, and it's called a tetrapod. The reason we call it a tetrapod is because, well, pod means foot and or like leg, and tetra means four. So we have this four-legged creature that is walking around, and it's actually this animal is the ancestor to most of the vertebrate animals that we see today. At least all the ones walking around on many times four legs. So reptiles, even birds, because they have four limbs, right? Even though the front two don't touch the ground, their wings. Mammals, amphibians, a lot of the animals we see today come from this ancient ancestor. This is like the Mercedes-Benz motor wagon of 1886, the OG. So let's look at the basic bone structure. I know this picture quality is poor. It was very small on Google and I had to enlarge it. So, bone structure of a tetrapod. These different colors represent different bones that it has. So, this upper one, this blue one, is called the humerus. You might be familiar with the humerus because we call it the funny bone. Not because it's funny when you hit it, but because its real name is the humerus. Here on the left, we have what's called the radius. On on the right, we've got the ulna. Those are two bones that make up the arm of this tetrapod from 300 plus million years ago. And then we have the carpals, which are all these kind of weird small wrist bones. And then at the very bottom, you got the phalanges, which is the fancy science word for fingers, basically, or toes, whatever you want to call it. In this case, it's fingers because it's the front leg. So these are the basic bones that we can find in fossils of this tetrapod from 360 plus million years ago. Now let's look at the bone structures of things that we have walking around on the earth today. First, we'll start with the human arm. Up here at the top, what do you expect this one is called? We have one longer arm bone. It is the humerus. Then it branches off into two side-by-side bones in the lower arm. So this is like your elbow. Down here in the lower arm, you have two bones side by side. And you guessed it, the one on this side is called the radius, the one on the side with your thumb on it. The one on the outside, kind of by your pinky finger, that's called the ulna. Sound familiar? It should. Here we have the carpals, this kind of conglomerate of bones that make up your wrist. And down at the bottom we have, that's right, the phalanges. So this should sound pretty familiar. Is it a coincidence that we have the exact same bone pattern? It's actually not. Let's look at another completely different animal, a cat. Well, up here at the top, it's shaped different. It's a little smaller and it comes in at an angle, but that is, you got it, the humerus. We have these skinny little bones, and the one on this side, the one on the left is going to be the radius, the one on the right is going to be the ulna. We have carpals, which are the wrist bones, and down at the bottom we have the phalanges. This should be very, very familiar. As you're coloring these, obviously it's going to take you a little bit to go through these. Make sure you're keeping a similar bone color pattern through the different examples that we have. I know that these two pictures, like up here, it was green, and if we rewind, it's brown over here, and if we rewind farther, it's blue over here. You should be keeping a consistent color for the humerus. So all the humerus bones should be colored the same color, and then change colors and color all the radius bones one color and all the ulna bones another color. All right, so that is what a cat leg looks like. Okay, whale fin. Let's move on to something completely different, something that spends its entire life in the ocean. Up here we have, yep, the humerus. Is it the same size and shape as the other two that we've looked at, the other three we've looked at? No, it's not. But we still have the same pattern. We have one bone at the top that connects to two side-by-side bones, kind of in the lower arm. We have a bunch of wrist bones that we're going to call the carpals. And then down at the bottom, we have these huge, long, extended phalanges. That is the fin of a whale. Same structure, but they've been modified to fit the needs of that animal. Let's move forward. Now we're going to go to something even more strange, a bat. At the top, we got a humerus. Now, this might be hard to see because this one is so small, but look closely. You do have two side-by-side bones in this lower arm. You got the radius, you got the ulna. It's the exact same as all the other animals. And then you've got the carpals, that tiny little wrist section right there. And then you've got these longer, extending, kind of fan-shaped phalanges. So is that, yep, that's the end of it. So as you go through and you color these bones, notice how they are all differently shaped, but how the pattern is still roughly the same. If we go back to the very beginning of this slideshow, when I went from here, the original motor vehicle, and how it is now diversified into all these different motorized vehicle types. This is the same as the tetrapod splitting off and having posterity, or having lines, like family lines, over the next 367 million years that diversify even more than a truck and a side-by-side, a Ferrari and a tractor. They have modified the same parts to fit their current needs, right? Like this Jeep needs these gigantic tires with a lot of great grip. Ferrari It's going to be low to the ground, aerodynamic for speed. You've got all sorts of different purposes, but the same original parts have just been modified to fill those purposes. And how we got from the tetrapod to all of today's amphibians and reptiles and mammals and birds and all those sort of things, the reason that we have um, all of these different varieties of life is because of natural selection. So natural selection, as this guy's posterity um, moved into different climates or the climate changed, they would have to little by little change for 367 million years until they are what we see today. And if you were just to look at a bird and a bat and a whale and a human and a cat, you might say those there's no way those have a common ancestor because they look so different. But looking at that bone structure, you can see how the pattern was used and just adapted for their unique lifestyles. Okay, I hope that helped. Um, Once you finish with this assignment, you can work on any of the missing or any of the assignment we started on Friday but didn't get to finish. And yeah, hope to be back with y'all soon.